Now we are going to apply the calculations in order to find the coordinates of the turning point of a given function, which could be minimum, maximum, or a point of inflection. Look at this example. We are required to find the coordinates of the turning point on the curve with equation y equals x to the power 4 minus 32x. Establish whether it is a maximum or a minimum point or a point of inflection by considering points either side of the turning points. We have three goals. Number 1, find the turning points. Number 2, define if it is a maximum or a minimum. And 3, to see the points near the stationary points in order to define if it is maximum or minimum. Let's do a recap on the steps. To find the coordinates of a stationary point, number 1, find gradient, then you solve gradient equals to 0. Number 2, you substitute to find the values of y. Number 3, give coordinates of stationary points to define if it is maximum, minimum by looking at the values near the point. Let's start. Here we have the function f of x. Sometimes it is called y and not f of x. So y equals x to the power 4 minus 32x. dy over dx equals to 4x cubed minus 32 multiplied by the differentiation of the x, which is 1. That means 4x cubed minus 32. This is the first step. Okay, now we will continue step 1. We need to solve dy over dx equals to 0. First, we need to factorize. 4 is common into x cubed minus 8 equals to 0. Therefore, x cubed minus 8 equals to 0. So x cubed equals to 8. By applying the cubic root, we know that x equals to 2. Now we say at x equals 2, we have a turning point. To find this point, we need to substitute in order to find y. Okay, but y equals x to the power 4 minus 32x. Now we substitute 2 to the power 4 minus 32 times 2. So 16 minus 64. That means y is equal to minus 48. Therefore, the point 2 minus 48 is a stationary point. We can say stationary or a turning point. Now we need to define if it is maximum or minimum or a point of inflection. Okay, now we take this table. Here we write x equals to 2, x less than 2, and x greater than 2. And we write the sign of the gradient, which is y prime or dy over dx. At x equals to 2, we know that the gradient y prime is equal to 0. What remains is less than 2 and greater than 2. We need to know whether the gradient is positive or negative. To calculate it, we take a value that is very close to x equals 2. So here we are going to take x equals 1.9, and for the greater than 2, x equals 2.1. Now we calculate the y prime for each. We simply substitute the y.9 in this equation in order to obtain y, and then we substitute the 2.1. Here the answer is minus 4.564. So here the y prime is negative. In the case of 2.1, we also substitute the 2.1. Y prime is 5.044. So here it is positive. Now for the shape of the curve. If we have a negative gradient, then the curve will look like this. If we have a positive gradient, it will look like this. For negative, it is decreasing. For positive, it is increasing. And at x equals 2, it is a stationary point. As you can see, the curve was decreasing. Then it reached a point where it stopped, and then it started to increase. That means this is a minimum point. Why? Because here it is decreasing and here it is increasing. So at 2 minus 48, we have a minimum point. Look at the book. We took the dy over the dx and we solved it. It equals to 0. Then by factorization, x equals to 2. And we found the value of y. The stationary points were 2 and minus 48. Therefore, we considered the gradient on either side, and we took the points 1.9 and 2.1 in order to see how the curve looks like. And then we deduced that it is a minimum point because it was decreasing and it stopped and then it increased again.